Hello. Let's test audio first to see it's all going well. Checking. Okay. Thank you guys. Thanks a lot. So, welcome for those watching here. This video is gonna be recorded for anybody else who could not join right now. But anyway, you guys who are here live are also welcome to ask any questions. I have here with me also. You see comments. Daniel and Justin are both from our team, both from the core Quantum Unreal team. Oh, it's not working now? Daniel said it's not working. Okay, yeah. I just charged this thing, so I should not have any issues with. Yeah, so we have the part of the team here, and we're all here to answer questions and also, but primarily now to showcase, to give a primer on the finally now available for Circle subscribers, very early but functional Quantum Unreal plugin. So let's get straight into it. So I'll get my face out of you guys and let me show a few things. So those of you who are Circle subscribers um, have already the links shared over our Discord, and you can get these two files if you clicked on there, right? Um, so this smaller file is basically just a raw Quantum plugin. Is just an Unreal plugin that brings everything you need to use Quantum to develop the gameplay and everything else. Whereas the second one is a full sample. So it's a working game that it's exactly the source code of the game that I've been streaming about on the previous Quantum Unreal streams. I'm gonna have add the links to those past streams here on this one later. But what we're gonna be doing today is I'll first show how you can get, let's say, a clean project or your existing project, and how you can add the raw just the Photon Quantum plugin into it, and what things to look at and so on. But we're not going to develop with it because it doesn't come with a demo menu, it doesn't come with a spawner or that kind of thing. That's the kind of thing you have on the sample. And normally I would say you should start taking a look at the sample, which we're also going to take a look today. And you would be understanding a few things how it works there, and then when you go to prototype your own thing, you're gonna get the raw plugin and copy a few things from the sample. I'll highlight a couple of useful things you can get from the sample that are interesting. Well, let's go down to this and try to do something, see how it works. So I'm gonna see if I have a clean. I think I don't. I'm gonna actually gonna open Unreal Engine here, just launch binary installation of the engine, and we'll try to create a new project with it. So let's give it a few seconds to load. We'll basically create a clean C++ project, and we'll import the Quantum plugin into it, so you see how it works and how you can import it. And I can comment on a few things. So I was testing this on a different one, but I'm going to create a new one, so we start from scratch. So essentially, Quantum is a C++ engine. Maybe in the future we'll be able to prototype stuff directly with blueprints only. We do integrate with blueprints more or less in several areas, but you cannot do a purely blueprint project yet. But you do a C++ project, you give it whatever name you want in here. This is not yet involved, does not have Quantum still. I'll just create a project here, let it load. Then we'll add Quantum to it in a minute. So as we're creating a standard Unreal plugin, eventually the plugin will be something that you will download from the Unreal Marketplace, or or you manually download with us and you install as an engine plugin. But for the moment, I did try to install it as an engine plugin. It should work, but it has a few quirks. It's not yet fully prepared for that. So it is fully working if you add it as a project plugin. And that's what we're going to do today, and verify the steps to check. It's still finishing everything. And then we'll check the config files and see that it's all ported correctly. It's just to give. I'm doing this here to record, so we can point to this video to anybody who needs to take a look at how to create a clean project and add the plugin to it. So let's do it. I think it's loading Visual Studio. I'm gonna actually remove all this first. Yeah, so the engine actually loaded here. So this is just an empty project with a started pack. I'm gonna close everything again because what we'll do for this then is he created the project here, and we have the whole project here, including the Visual Studio generated solution and all that, but it doesn't have any plugins folder. So I'll just create plugins here. And what we can do then is we can grab the file that you downloaded, and unzip this guy. Or it's taking a while to, yeah. And then you can copy the actual plugin folder directly in here. And then here's the trick. This is not going to automatically load into Unreal. There are a couple of things we need to do. So I'm just going to edit this with Notepad, but what we do is we have to go here, and right here we need to add the dependencies to the plugin, because we're just going to directly load the module here. That's going to work. So let me let me copy and paste here so I don't waste time with a wrongly written. Which one? So we just need to add the additional dependencies entry here, put it as the Quantum module, which is one of the modules of the plugin. We can, just for precaution, I'm generating the Visual Studio files again. And this should be good to go. So let's load Visual Studio here, and because this is normally the workflow when using a real C++ project, right? So you actually load either Rider or Visual Studio. You go there and build, and oh, I should have just pressed F5. Let me. This way, I already clicked, so I'll wait. You actually build and load from here, and then you work on content directly in the engine. I'm just making sure everything is compiling. Yeah, you can see that the plugin actually loaded from here. It comes with it has two different modules, Photon Quantum and Quantum Editor. It has a bunch of sources in all this. There is some stuff distributed as libraries as well. So project is compiling fine. I'm gonna load the engine here. One note here, as we've been discussing this on Discord with one of the customers. Currently, Quantum Unreal is supporting Unreal 5.2. We don't support yet Unreal 5.3. We're gonna take a look this over the past few weeks, but we have not yet had the time to do this. So please start using this with Unreal 5.2, prototype something so you understand how the whole thing works. But then eventually you're gonna drop also support for 5.3. So it seemed that for him a few things were like complaining in terms of compilation. So we're not, but we'll not invest a lot of time into this right now. So actually, for importing the plugin, this is what needed to be done, and the plugin is actually already available. If you start creating C++ classes and define and creating blueprint actors that use the Quantum provided components, or even the base classes for actors as well, it would all be possible already. But because we don't have a demo menu, we're not going to do a lot of here. What I'm going to show on this one is that since we installed the plugin successfully, we can actually check that by looking at where is that we look at plugins. I forgot. Added plugins. So if we see here on installed plugins, you see that networking, you have Photon Quantum version 0.1.0. So we successfully installed it. And one interesting thing I wanted to point to is that if you click here, you are pointed to this, better. So you're pointed to this, to the quick start guide that we just updated today. We fixed any typos and any type definitions that we changed names. Everything is kind of cleaned up to match what the version of the plugin that is being shared has. So, so we did this carefully today, and it is good to go. It's a very basic entry, but it together with the sample, it should be enough for you to get a basic understanding of how to write gameplay with Quantum. And so for those of you who have seen the streams and everything, the most important modification is that we changed the name of the deterministic types from F fixed to FC from Corium, which is the core part of C++ libraries we're doing now, including for Quantum, C Sharp, Quantum Unreal, Fusion, in future projects as well. But so we change for FC and then the type name that you need. So we now the numerical type is FC real, and the vector is FC vector 3 or vector 2 depending on what you're using. So that kind of thing. So we have also FC quat for quaternion. And that's it. That's the main modification. Everything else is very similar to what it was before. So plugin is correctly installed here. One thing you can also do is you can take a look at, so I can check on project settings. No, it's not project settings. It's on the content view settings here. I can show plugin content. When we see plugin content, you see that the Photon Quantum comes with a lot of basic configuration assets like the session config that allows you to control simulation updates, rates, max player count with support, and a few other things. And some of these topics were covered already on the previous stream, so I'm not going to get into too many details here. But another interesting entry point that is important to take a look at is that, and we'll be adding a lot of stuff for this one, is that from the project settings window, you also have access to the Corium settings, which is Corium, as I said, it's the core part of the Photon libraries that we share for all these new SDKs. And you can assign here what is the default settings you want to use for the things, and a few other configuration options for the subsystem, and even which inputs uClass implementation you want to use, and so on. We're gonna see this on the other project now. So I just wanted to give an overview of how it should look like if the plugin itself was installed correctly, which is the case in here. But I'm not yet gonna develop a game with the raw plugin during the stream. This is a short one. We may start doing another one next week. Um, from scratch again, but I wanted to give this overview at least of installing the plugin on either a clean, new, or an existing project. And it's as easy as this. At least you install the libraries, everything is compiling fine, and if you add the right entry points to the code now, you will be able to use it directly as the raw plugin like this. And for those who maybe joined or are seeing just now, we installed it as an in project plugin, meaning that we created a plugins folder directly in the project and added it here directly from the zip file we downloaded. But eventually, you'll be able to also install our plugin directly into the engine installation plugins folder, and you will just be able to import it directly into the just reference it directly into the project. Because even this one here, you're not going to be modifying any source code in this. You shall use it as it is. All modifications, all source files that you're going to be playing around with are going to live in the project itself in your own modules. These are to be used as they are. So it is not yet working as an engine installation plugin, but it will work as well that way in a few weeks, max. Let's see. For now, it already works as an in project plugin. Okay. With this done, let's move on to the other project, which is the sample that can also be downloaded. It's a much bigger file, so like half a gigabyte compressed, because it has a lot more content in it. So I already have it running here. I'm not gonna spend too much time into setting up things, but if you download that project and you right click on your U project and you make sure to generate a Visual Studio project, and of course make sure to check that you have an installation of 5.2, either in one that you compiled from source or a binary one that you have installed on your development machine, but it has to be a 5.2. Generate your Visual Studio. Unfortunately, I clicked on it, but it's fine. It's just generating the files again. So generate the Visual Studio files, and you're good to go. It will not have all these folders here because I already compiled this one once, but it will be created the first time you do. Um, just giving some time for it. Oh, sorry, it already loaded. Colleague was asking something. Um, okay, let's build this one now. Let's make sure it's all clean, and then we'll load it. Yeah, I already had it built, so press F5 here. So we load the engine. So as I mentioned already, this project is actually so I have been talking and streaming about this project for a while already. So there are two recorded streams on this, which is a racing game built with Quantum. Um, Justin, who recently joined us, is working on this project. He's gonna try to add the racing AI to it, and we'll talk about it at some point. But this here already has multiplayer racing with checkpoints and a few interesting logic entry points for you to test. And the most important thing is that you can learn how to use a few things in. So, what are the most useful things you can take a look at here? So, I would say one of them is that this has a functional um, UI menu that allows you to connect, start the game, and run in multiplayer, which is how you can test it. So, and it does this from this menu widget that it is possible to copy over to another project if you don't want to create another one. But you can also take a look at the logic. It's typical blueprint stuff. But you can take a look at how the buttons interact here with our subsystem, which is a game subsystem in Unreal. Basically calling the methods to connect, join a room, and start the quantum simulation, or dynamically add a local player. So these are being done either from this menu here. By the way, I covered this when I talked about this project on the first stream about it. So this is already explained. I'm just being a bit redundant here. But I'm now using this. I'm basically saying that you can copy over this menu to the other project, especially if you also copy some of the base classes that come with this. I forgot to close the other project. So, namely, a few interesting entry points in here are, particularly from this project, are, I would say, the quantum player spawner is a very interesting class that comes with the sample that can be that's very generic, and you can use it for any other project that allows you to. So we even cover the concept of sending player choices as runtime player. It even encodes that as JSON, which plays nice with webhooks. I need to talk about webhooks and Quantum 3 in a minute because Quantum Unreal uses the same backend as Quantum 3. Um, and but most importantly, this player spawner can be used to add the local player, spawn an actor that the player can control. So in this particular sample, it is being used to when Quantum is started from that menu, this class is used to dynamically request the addition of a local player for this client to control, and when that is confirmed, the car is spawned on every single client. And as I said before, these topics are covered on the other stream, but it's still interesting to take a look at these classes here. Um, Let me take a look at the question we have, and then I will show. I'll talk a bit about the app ID. Uh, so about AI, no, Sahin, not at all. What we have in C Sharp is 7 years of history building the engine. So the bot SDK is exclusively built for Quantum C Sharp. Nothing from that bot SDK exists here. Quantum Unreal, if you have not seen these streams before, it has nothing to do with Quantum ECS C Sharp. It's a totally new implementation in C++ using Unreal actors. It's not an ECS, it's nothing like that. It's totally built on top of Unreal. What we have here is we have the 3D physics engine completely integrated into Unreal components. We have transform, we have the whole deterministic math library and framework, and a way for you to spawn and despawn Unreal actors that include data that is deterministically predicted and rolled back. But it's a totally different take. I suggest you to take a look at the documents, samples, streams, because it is the principle of predict rollback is the same. The implementation is completely new. It's a new engine targeting a new engine, so it doesn't use anything from Quantum C Sharp, except for the backend on the server that it's the same as Quantum 3. There's many reasons for this, but C Sharp is useless on Unreal. It's not an officially supported language. It's it's much better to just dive into C++. When you move from Unity to Unreal, you have to switch your mindset a lot. About the list of streams, there are actually only 3 streams I did about Quantum Unreal, right? So which is the and yeah, I'm gonna link all 3 of them into the description on this one here. Sure, there was a node primer for how the whole project is set up. That's still mostly useful because it explains how you add predict rollback data. And there were the 2 streams about this particular project, which are very useful. The only thing that changed from back then to now is the numerical type names. The APIs are the same, but the names of the numerical types changed since then. So that's the only correction. But so yeah, the last thing I wanted to show is I'm gonna run this so you guys see how it works, how it runs. But what I want to actually show is that let me. So let's say you are on your photon dashboard. So this is something that we want to do is to use Quantum Unreal, you need a Quantum 3 app ID. So what you do is you can create a new app, or you already have a um, Quantum 3 app ID. You may be able to reuse that, but essentially you're going to select Quantum here. You're going to use Quantum 3. Please do not use Quantum 2. It's not going to work. Use Quantum 3. Find a name for your application. Hit create. Copy that app ID to use. That's all you need. So you're going to use a Quantum 3 app ID for Quantum Unreal, and that's it. I already have one that I'm going to copy here. Just going to copy here, so I'm going to show how it works. So when you run this project, you'll see that the menu has a few things. So it has a room name that if you are playing with others, you can if you're play testing with others, you can define a room name. This is not technically user ID, it's just what we call the client ID in Quantum for those coming from Quantum C Sharp. It's the concept of unique client ID to reassign player indexes again, the same ones if you are reconnecting to the same room. So make sure to use different ones on the different clients if you're doing that. But the third one, which we just deleted the app ID for the sake of distributing the project, so it's empty here. That's basically the space for you to place an app ID. So that was my app ID here. And if you do this, you're going to be able to connect. And if you wait enough for it to show the to state there, you can actually do join and start. And this is actually going to start Quantum. I'm going to do this now. And when I do that, you are actually running Quantum. This is the sample. This is the racing game done with Quantum. This is all done with our physics engine. Everything is doing full predict rollback here. And actually, one interesting thing you can do is there is this can enable these Quantum stats one here, and then you can see. Actually, I think I I clicked it for too long and I disconnected. So let's try again. So I'm gonna paste again the app ID, guarantee that I get to a different room name. And so with the stats enabled, it's good because you can take a look at how long the simulation takes to run. So about 2 milliseconds here in total. And you can see tick number, how many prediction ticks you are running, and a few other interesting stats. So it's useful to keep that running during development for checking a few things. But yeah, I'm not gonna explain much about the gameplay here because there are the previous streams that already talk much better about that instead of doing it now. So but I'll just quickly demonstrate with two different windows. I have to do one thing though before I do that. So I have to run under one process. I have to disable this because I want to really isolate the processes running multiple instances. So let me try to run two multiple instances. Am I still muted? Okay. How much did I... I'll keep this connected here. I'm not sure if I didn't charge enough. So I am not sure this laptop's gonna be able to run both, but let's see. So I'm gonna add the app ID here. I'm gonna make sure we run with the same room name, different usernames. Connect the first guy, connect the second one to the server as well. Um, okay. So let me just see if this, I'm not sure if this machine is going to be able to, but I think so. Yeah, so see, I'm moving both. The problem here is that it runs very slowly when it's out of focus, so it's difficult to get to see from the other when that's going on. But it is working in sync. As long as you are in focus here, it's gonna run fine. When you run under one process, it actually runs, of course, super quick, but it's not recommended to do that because you are reusing the same objects. Quantum itself actually works under one process with the two instances, like the way the default engine works, but the UI may get messed up, so we don't recommend doing that. But it is a possibility. Yeah, so this is also demonstrated on the other streams. I am keep repeating that, but that's a bit the point here. So yeah, it's all working fine. This is fully available for Circle subscribers now. And I hope you guys enjoy using this over the weekend. Hit us with questions over Discord. As I said, please, Unreal 5.2 for now. We're going to add support to 5.3 soon. But and if you have more questions at the moment, ask now on the chat. Um, I'll wait for a few questions here before we finish for today. Okay. So maybe the only questions I had were from Sahin, so not sure. There is a delay on the stream, so I'll wait a bit more to see if any question will come. I'm also checking here on checking Discord. I have questions on Discord. Okay, another one from Sahin. Let me check here. Um, no, Sahin, you cannot use Unreal for gameplay because Unreal systems are not deterministic. They are not prepared for predict rollback. That is a bit like how we started in Quantum in 2017-18 that we had to always explain this. Quantum is the game engine. Unreal becomes just a rendering engine. And this is the price you pay for doing predict rollback determinism, right? So but if you think about interesting games done with Unreal, I would give many of these games don't use the Unreal built-in systems, right? So I'll just give an example. So there is this new RTS called from Frost Giant called Stormgate. They basically built their own in-house quantum for 32 players. Everything gameplay AI, everything is in-house. Everything is custom built. But since you asked about future plans, let me say a few things about this. So today we dropped support for the plugin with the physics engine math. This racing sample that I've been streaming about for a few months already, but we have two other samples that are already developed, that were actually developed even before this one. We're just cleaning up them and updating to the latest library. So Justin is doing this few days actually, and we'll drop these other two samples in the next week or two. One is a kind of brawler game where you are robbers and you have to collect money bags and beat up some policemen that try to beat up you, and you have to collect this money to the extraction point kind of thing. It's just a fast-paced brawler thing done with Quantum, like on a rooftop or something. So this is ready, and then the other one is a capture the flag, a physics-based capture the flag on top of vehicles sampled. So it uses the same kind of vehicle physics as this one here, but it's set up totally different. It feels totally different in terms of vehicle physics. If we have plans to build more samples, absolutely, a lot of new samples are going to be built over the next months. But not only samples, but we're going to be adding a lot of features to the engine itself. So one of the next things we're tackling is nav mesh support, because again we have to build our own nav mesh. We have experience with this by having done this with Quantum C Sharp, and we have already a lot of work done in terms of getting the getting recast and detour, which are the industry standards for nav mesh, which is what the Unity uses underneath, it's what Unreal uses underneath. We have our own deterministic fixed point based um, port of recast detour C++, and we're now working on getting the glue to have the quantum components for you to be able to use navigation, nav mesh agents, and that kind of thing within a quantum game. And as for AI, I don't think we plan to build something like the bot SDK, which is, but we may create a not, I would not say simplified, but the idea for Unreal is to give a lot more stuff in source code. So, for example, if you think about the Quantum Bot SDK, we have our own custom visual editor because Unity doesn't have a good visual editor at all. Unreal has blueprints as a visual editor for setting up things and creating classes. Is amazing. So we would just use something like that. So we would definitely try to do something that integrates well with blueprints if we are to build an AI editor. But definitely not using Unreal behavior trees, because those are not deterministic, neither prepared for predict rollback. So that is not possible. No. Um, yeah, flow fields. So flow fields are very, very far into the thing here. It's not even on the roadmap, to be honest, because flow fields are a very specialized thing if you're building a massive Pathfinder kind of thing. And the idea is that you shall be able to do it yourself as well if you need to, especially in these early stages. Honestly, we're gonna be trying to cover the most used things, and there's a lot of things that come before flow fields. So unless there is a very special case, like a very interesting project that pops up that would require that, we don't have it in the roadmap yet. Although, yeah, definitely something that you should try to do and add support. One thing we think we could do to help that. So just to be clear, because if you see how flow fields are implemented with Quantum C Sharp, if you pay attention to that, they do not actually use the ECS. So the flow fields are implemented with custom data structures for the grids, for the patches, and for all that. The only thing they use is they use the dynamic heaps that Quantum has. in C sharp. So the buffers for the patches and for the flow fields, they are stored into custom allocated um, pages of this heap. And what we can do is so Quantum Unreal underneath has the same heap. Let's say it's not the same heap implementation, but it has the same concept of a rollbackable heap underneath. Actually, every all the quantum memory in Unreal runs into the heap. In Quantum C Sharp, we actually have two parts of the memory. You have the entity memory separately with the component buffers, and the heap for dynamic collections and custom allocations. Um, Here in Unreal, everything goes into the heap. So the heap is rollbacked. So one thing we could do that would, so if somebody comes and, oh, I would need to do something on flow fields and so on, one thing we can definitely do is it shall be possible for us to allow direct access to the heap to allocate something in the heap, keep a pointer to it, so you would be able to keep your own buffers for your flow field patches and so on carefully. And that kind of let's say expanding the API to expose the heap for custom allocations that can be predicted and rolled back is something we could work on. Yes. So let's see what pops up as people start using it. So thanks a lot for the questions. They were all very good, and I apologize a bit for some of the answers being no, we are not gonna do that in particular, but they're very interesting because it is important for everybody to understand what it takes and what it is necessary when you go down the route of determinism, which has uh, amazing pros. Um, but of course, you have to be aware of what you're doing. Okay, yeah, please do. And Meep, thanks for the nice words. And oh, so the heap is already directly available, right, Daniel? Yeah, I did not know that. So that's cool. So yeah, so if anybody needs to do something more low level like a flow field implementation, technically the memory access is there. And yeah, we may come up with a small text sample with that, but yeah, I just don't see flow fields as an immediate goal. I definitely we would add nav mesh support and agents before that. Okay, I still have a few minutes, and since I had a few questions, let's see if another one pops up. I'll give a bit more time here. Let's see. Not yet. But it's another very, very good question, and I've been thinking about this a bit. So one of the problems with replays in the Unreal version of Quantum, Sahin, is that we took this approach of it's a bit like Fusion for Unity in that we in Quantum Unreal in Quantum Unity we have this very very decoupled simulation in which we have the ECS entities and we have the VL, which are game objects, and in that and the way a replay so let me answer your question in two steps. A replay runner for running a full replay of a match or from a certain frame forward and being able to go back and no, let me stop the go back thing for a while. Let's first say you want to run a full replay of a match and see how the game played with a different camera perspective. Yes, as soon as we add the support for the local runner, actually a replay is not far from it because it is the techniques can be used, and the whole thing about quantum being um, linked to actors mean that it would be the same as running the normal online game. You start from the same map, which is the concept of scene in Unreal for those coming from Unity. So If you start from the same map with all the initial actors you have on that map, and we start with a replay, we just replay and add and remove the actors that come with the replay, with the inputs that come with the replay running the simulation. So yes, that will definitely, there is nothing on the current approach that even creates a problem with that. So it will work fine as soon as we add support to it. We don't have it yet, but it will be added. But the other type of replay, which is kill cam replays, in which the way they work in Quantum C Sharp is you are running the online game, we spin up a second instance of the game that runs concurrently, running just the replay. And what we do is we link the view, the scene and the game objects that you are watching, we link those to the replay instance and not to the main instance of the game. The problem we have with that with Quantum Unreal is that I just saw that this is misspelled here. It's called Quantum. I'll fix later. The problem we have with that with Quantum Unreal is that we chose this approach of integrating everything with actors. So say you had a couple of characters and a ball playing the game, and then we at one point in time the ball is despawned. So if we want to replay and start again, we have to respawn this ball instance because it doesn't exist anymore. So we need to check how that would work, how we would relink pointer references and some other things. We can definitely respawn the actor and fix the links that are kept as part of the quantum gameplay, but it might break the UI and a few other things. So it is possible, but it is a little bit more challenging than it is when you have a fully decoupled framework like the ECS we have in C Sharp. But so kill cam replays, they might be possible, but they would require, let's say, the developer to be aware of a few extra things to make sure his UI and his non-gameplay related things in these actors would be clean. One approach that would make this work is that if you make the quantum actors only contain gameplay data, and then that would definitely be make kill cam replays easier to use. Yeah, but the problem with kill cams with actors is this: is that so in one way, Quantum Unreal is much easier to use once you understand how it works than it is the ECS because it's much closer to Unreal API. So this is something interesting here. So when I say it's much closer to Unreal, it does not mean you can reuse the Unreal existing behavior tree or Unreal existing physics engine on an Unreal existing character controller or anything from the infamous gas thing. No, you cannot use those. That's not what I mean. What I mean is that the source code looks a lot more like a normal Unreal source code. You create blueprints and you edit the properties on blueprints. So let me give an example here. So how is this car edited? So you get the car, it's a blueprint. So it's a blueprint class that you even have a bit of a blueprint code for spawning the camera. But I don't care about, I want to see how we set up the visuals for the car. So you see that there is a camera on it. It's a normal, it has the visuals, it has a hierarchy of components here for the visuals, and you add the quantum components to it. So you have a quantum transform where you can define even initial rotations and things like that. Because this is a blueprint, this is actually going to be overhauled when you spawn. But for example, you have a collider, and this collider is a compound collider type that you define the shapes, and the way you define the shapes here is actually visually here very similar to the way you define a compound shape on an on a chaos engine collider component. So we use the same kind of conventions, the same kind of naming conventions, so things feel as similar as possible. We have a physics material that's a data asset very similar to the chaos physics material as well. Um, So that's what it means. It's very similar to Unreal. You have actual Unreal components being the predict rollback data. And if you look in the source code in the documentation that I showed, that's linked for you guys who have access, um, rollbackable properties are just regular Unreal U properties with a slightly different syntax sugar to them, but they're just so that's what we mean it's very close to Unreal. Not that you can use the Unreal existing stuff, but you use our stuff and they feel just like the Unreal normal stuff. But so this is going to make it easier to start. But unfortunately, this creates a little bit of challenge for kill cam replays. They will be possible, but they would mean that you would have to adhere to a few more extra careful approaches to make sure you can always reset the visuals when running a kill cam. But it's definitely something we will experiment with the next few months. Full replays would be much easier to support from and they will come first as well. It's in terms of the technical on the memory aspects of things, to be clear, it's very easy for us to reset the game to a previous state that was a very far, let's say 10 seconds before, 20 seconds before. It's very easy to reset the heap to a state like that, but we would have to actually serialize and deserialize, so we would be able to respawn the actors, because we need to make sure we would respawn actors that were despawned before, and despawn the ones that were spawned during the replay. So that's what makes it a little bit more challenging. And we do have the serialize and deserialize for it, but we need to do this without breaking the main game, so it's a little bit more involved to do a kill cam replay with such an integrated approach. Okay, one more time. We have about 5 minutes, so I'll wait that, and if we have a few questions, I'll answer. If not, um, then that will be for today. But let's see. It's a couple more minutes. And thank you for the questions. I think most of these were not things I tackled before on previous streams, so it will I will edit the chapters and list the topics of these questions, because it might be interesting for us to see our take is on all this. And besides sample, we plan to stream a few more times about Quantum Unreal, of course. Let's see how that will play out over the next few weeks. Oh, yeah, documentation will start adding a lot of stuff already next week. So um, we'll actually, so I can show just a bit of structure here, because we host this single quick start guide here as part of the old Quantum 2 docs. So what you can expect is that we'll have a new product here called Quantum Unreal. So it will be a full new entry here, and we'll have an intro. There will be the same quick start guide that we have here will be there, and we'll slowly adding more things. So we'll add more stuff about the physics engine. We'll add more about how to install the plugin. We'll add a kind of like an 100 series tutorial for you to go step by step. So yeah, you can expect this to start popping up, but it will take some time because we'll do this at the same time as we're developing the engine with the team. Yeah. So yeah, makes sense. Sorry, yeah, I apologize for that, but Quantum uses. So let me show you something that is interesting because of that. So it's a new product. We made sure to use the latest version of the Quantum backend tech as well. So one interesting documentation that will pop up on day one is this one here. So if you look into Quantum 3's doc, there's a section called webhooks. So the Quantum webhooks that can validate the player choice is sent with runtime player, the runtime config, and the deterministic config, which is the session config that you have also here on Unreal. So the webhooks that can be used to validate all that with a backend, they are 100% compatible in C Sharp and in Unreal. So we made sure to use that. So basically this document here, the webhook doc for Quantum C Sharp, it's verbatim the same and it works exactly the same way for Quantum Unreal. The only thing is that if you see here that Quantum has this runtime config class, which is the runtime config object, and blah 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 blah, it is encoded as JSON. If you look at the project that we have open here, it is here. Run f runtime player. It's a struct instead of a class, but it has the same name, and this is actually encoded in JSON and decoded back in JSON because it is 100% compatible with Quantum 3 webhooks. And the same goes for the runtime config struct, which also exists here in the project. So the same concept that exists in Quantum 3 for webhooks exists here. It's also JSON and it works from day one. And this one here, which is let me close this. So the session config, which is the deterministic session config in Quantum C Sharp, we're here just not exposing all the parameters. I exposed only the important ones that people actually play around with. So, but it does have the other one hidden inside. So this is serialized binary. It's not JSON, but it doesn't matter because the plugin serializes it in JSON to your backend. You can actually validate these configuration things from your backend back to Quantum Unreal. It works exactly the same way as in Quantum C Sharp from the perspective of webhooks. So the enter room parameters, the session config, which is the one that I just showed. So see player count here, it would be this player count here. And then you see the update FPS that you can validate and send from your back. And yeah, it is the one you have here, update FPS. So this is already working. So if you take a look at Quantum 3 webhooks and you're using Quantum Unreal, it's already possible to use right now. So yeah, that's why we use Quantum 3. But we'll actually create a whole new session here for Quantum Unreal. This quick start guide, the webhooks doc will be shared, linked from there because it's exactly the same. So yeah, but I don't have any ETA for when this is gonna drop, but over the next few days and weeks, we're gonna be adding a lot of content. And well, now it's really time for me to finish. And so thank you so much for the questions. They were very useful for me to be able to explain a few things. And hope you all enjoyed. And the video is gonna be up, so you guys can rewatch in double speed or whatever is needed later. And please, you can just check our official channel where this stream is being from, and you can see there on previous streams you're gonna easily recognize this game. So there are two streams about it. Take a look at it; they're useful. and but I will link them from the description soon. Again, thanks for watching and have a nice weekend, guys. It's a Friday. We decided to deploy this really because some brave people would like to take a look at it over the weekend. We will not be online, but we'll be back on Monday, and we can help out for those who are Circle subscribers. So thanks a lot again. Have a nice one.